Alrighty, so here we are with the 5-6 notes. We're going to solve some systems of linear inequalities. So the only thing that's going to be different here is that the inequality is going to have, instead of an equal sign, it's going to have a less than or equal to, greater than or equal to. So that's what's going to happen to replace that. Little definition of a linear inequality. Again, it's similar to a linear equation, but because it's an inequality, the equal sign is replaced with an inequality symbol. So we get these instead of an equal sign. The solution of a linear inequality is any ordered pair that makes the inequality true, and so we end up actually just giving it a shaded region. So we'll kind of talk about that, but because there are so many true solutions, we end up talking about a region versus 1 or 2 points. So when it comes to graphing a linear inequality, here is kind of a visual of the shading idea. So let's say that you're looking at this line as the one being graphed. All right. Notice that it's a solid line, and because it's a solid line, that's because it used a greater than or a less than or equal to. Okay, so that's your solid line, versus if it was going to be a dashed line, that was because they used a less than or a greater than with no equal to part. Okay, so that's one of the pieces. The other pieces is shading above, meaning all of these dots up here, no matter which one we're talking about, all of them are solutions. And so in that case, we're talking about shading above when we have a greater than. Hopefully that makes sense. Above is greater. And then the last one here is below, and that's going to be a less than symbol if you have it. Alright, so whenever I think about below or above, usually I go to the y-axis. So if you go to the y-axis and find where it meets the y-intercept, then you're talking about shading below that y-intercept, because some of them it will be a little bit hard to understand if something is below or above. So just going to that y-axis and using that, which we will do in an example. Well, that's not helpful. Kind of already did it. Okay, so let's pretend that's not there. The idea here is that we're going to graph the solutions of the linear inequality. So we're going to graph this equation. And so we're going to pretend that it's y equals 2x minus 3. And that's why this 3 is given a point. And then up 2 over 1 is your slope. And then from there, then we get to go back to this idea of what symbol are we using. So notice that we are using a less than or equal to, which means it's a solid line. And so that's why over here we have a solid red line. And that other piece also means that we are going to shade below, right? We have a less than or equal to symbol, so we're going to shade below. And so that's where this piece comes in. All right. Again, you may think that this looks like it's to the right of the equation versus below, but that is because, again, if I go to the y-intercept, below the y-intercept should be shaded, and then it kind of indicates this whole thing. Above the y-intercept would have been up here if we were talking about a greater than symbol. Alright, so just a little helpful hint, the point 0, 0 is a good test point to use if you don't understand this whole below or above idea. So sometimes you can just take 0, 0, and you can say, okay, well if I put in a 0 here and a 0 here, is 0 less than or equal to 2 times 0 minus 3? And since that is 0 is less than negative 3, and that's not true, that means that this side is not going to be shaded, but this side is, because that was not a true statement. So you can always use that testing point if you want. So moving on to the solutions of a system, because now that we can sort of graph and shade, what happens is there's this double shaded region, and the double shaded region is your solution. So you're going to end up having a shade because maybe this piece was below it, and then for the other line, this was below it, but you need to find where the green and the purple meet, and that's your official answer solution set. So again, as much as the green was great and the purple was great, you're looking for the double shaded region versus just the singularly shaded. All right, they also have this idea of what is a solution and is not a solution. So here we are in this purple region, or reddish, I don't know what we'll call that, and 2, 1 is within there, and so that is going to be a solution. Versus if we were trying to use this point, for instance, that is not going to be a solution because it's on a dashed line, and remember, dashed lines are not parts of the solution. Also anything up here, or over here, or over here. Usually if I'm looking for not solutions, I definitely go for this white part just because it's a lot easier to double check that it is in fact not a solution. Alright. So we're going to tell whether the ordered pair is a solution of this given system, and so all we need to do is find out if it's true. So if we plug in an x of -1 and a y of 5 in the first one, that means we're going to have is 5 less than or equal, just less than, -2 times -1 minus 1. So we're trying to see if this is less than, and let's see, 2 minus 1, so is 5 less than 1. And 5 is not less than 1, and so it's not a solution. And it turns out that we don't need to check the second one, because if it's already not a solution in the first one, it doesn't matter if it's a solution in the second one, because it wasn't in the first. So, don't need to check the second. So again, if the first was true versus false, like this one was, then we would plug it into the second equation. Alright, so we're going to go ahead and graph a system of linear inequalities here, and then we're going to give 2 ordered pairs that are solutions and 2 that are not. So these are both already y equals, and so remember that we're trying to pretend that we're graphing y equals 3. So we're going to graph y equals 3, but remember that that's just an intercept. And so that actually means this is a horizontal line at 3. And so if I make a horizontal line at 3, and then I realize that this less than or equal to meant that it was a solid line, and the less than or equal to meant that it was going to be shaded below, then I would be talking about all the solutions down here. I can't really fill in the whole thing, so I'm just kind of squiggling. Okay. Then the other one is going to be y equals -1/1 x plus 5, just kind of giving myself a slope. And 5 is the intercept, so that's where we'll start. And then -1, meaning down 1/1, is my line, or my slope for that line. And it's probably good that you don't fill it in too heavily, because otherwise you wouldn't be able to graph very well. Alright. And then looking back at the equation, we have a greater than symbol, and so that means that we're going to get a dashed line. And so each of these points is not exactly going to be part of the solution. And then we're talking about a greater than symbol, and so that means I'm going to shade above. So again, above means here is my intercept above that intercept, and then of course any piece along that above part. So then you're looking for the solution, and the solution is actually where these two meet. And so the solution set is this black part over here. Alright, so then they want 2 ordered pairs that are solutions and 2 that are not. So very easily you can say, I guess I'll use red for not. So over here I can definitely say this point right here, -8 4, 5, 6, negative 8, 6. Definitely not a solution. I can even go as far as going down here because, again, it's not in that black area, so it's fine. So negative 2, negative 6 is not. However, the ones that are a solution are going to be over here. So let's see. 0, 6, 7, 8, 9, 9, 0. Definitely a coordinate point. And then even over here, 10, negative 2. But of course nothing on that actual dashed line. So this one, for instance, could not be a point because it's on the dashed line, and dashed lines mean that the point is not part of the solution. All right. So then we have the last one here, and this kind of goes with our parallel and systems that talks about if something could in fact ever meet or have a solution. And so we're going to have a parallel set of lines, which is fine because sometimes they intersect, but sometimes they don't. So we just want to be careful about what we're graphing. So this first one here, again, my intercept is negative 4, so I'm going to start down here. And my slope is negative 2 over 1, so down 2 over 1, down 2 over 1, etc. And then also up 2, left 1. Whoops. And then once you complete that, we then have to identify what this symbol means. And so that symbol will mean that we're going to have a solid line. And then it also means that we're going to shade below. So we've got our solid line. And then remember that below where it meets the axis, the y-intercept, below would be here. So we're talking about technically what feels like to the left, but it is below. Alright, and then the other one, we've got a y equals negative 2 over 1, same slope, but now we're intercepting at 5. So down 2 over 1, down 2 over 1. This one now is going to be a dashed line. And then we're going to be shading above. So it's a greater than. So dashed line. And then again going to the y-intercept, we're talking about above, so up here. And so remember that the solution is where they both meet. Or overlap. Since there is none, there are no solutions. Very interesting idea there. So again, some of them were above this line, others were below this line, and so they didn't actually ever meet, and so there's no solutions. And so that can happen when you have parallel lines. So those are kind of the special systems. Alright, so that is graphing linear inequalities. So all we need to do is make sure that we remember this idea of what is solid or dashed, what is shaded above or below, and then find that kind of double shaded region as your solution.